All right, everybody can read that and see it, right? We're good. Can I move around with the mic, or do I have to stay up here? Just do whatever. All right. Can everybody hear me? Raise your hand in the back if you cannot hear me. Too late. Sorry, guys. All right, cool. I'm Jaime, and I'm going to talk to you about building Windows Store apps with HTML and JavaScript, and I'll add a little bit of Facebook integration stuff so that you guys know what to do. Show of hands, just so I know who I'm talking to and how long to take. How many of you are web developers? All right, most of you. The ones that are not web developers, is it like iOS or, is that right? Anybody that does Windows development? All right, C# guys in the room? All right, we'll have that following, so I'm not talking about that as much. All right, perfect, good. Let's go with that. So first thing, and you got this from Kathy, right? If you got, from Kathy's session, one of the things that you would have learned is that the Windows 8 platform where you build Windows Store apps, you can write applications with either C++, C#, BV, or HTML and JavaScript. And the one thing that I want you to take out is when we talk about building applications with HTML and JavaScript, these are first-class apps. You have access to absolutely everything that you would if you had a native app. Right, so this is not a, hey, we're running inside the browser. I'll walk you through a lot of details, and you're going to see that these are first-class apps. You have access to the whole platform. You have really great performance. We've done a lot of work to optimize the platform, even beyond where HTML is at today. So you'll be in very good shape if you decide to use this technology. Our goal here was pretty simple. We thought, hey, everybody has the skills. Everybody knows how to code HTML, JavaScript, so they can just reuse their skills, even though you do have to learn a few things about writing code for our platform. So that's kind of where we're at. Any IE haters in the room? Couple? Yeah, that's okay. So first of all, I do want to admit, the platform is built on top of IE 10. If you're an IE hater, go watch this video in the middle of the night. It'll make you laugh. Where I'm at with IE, and I'll be candid, here's the way I think about IE. So for those of you that are thinking, oh, IE 10, IE 6, 7, 8, totally hear you. We were asleep. 6 and 7, we were asleep. 8, we kind of woke up and we started revamping our browsers and everything else. I think IE 9 is a pretty good browser today. And I'm a web developer. I write Facebook apps, I write Canvas apps. I'm in the trenches every day. The WebKit, and she's nodding, so a lot of people are noticing that, hey, IE 9, we made a lot of progress. With IE 10, we caught up and we kind of leap forward. So for example, if those of you that are fans and really get the standard stuff, this is a little bit of what's in IE 10. So you see a lot of the latest HTML5 specs are already there. Right, so when you're looking at, hey, the platform's going to be IE, don't be scared. Just try it. Right, we have a lot of the standard stuff. You have everything that works, everything that as long as you're using standards-based stuff on your code, you'll be okay. Right, if you're using prefixes, you might have to swap prefixes, but everything else will work fine. So don't be afraid when you hear that it's all running in IE 10. IE 10 is hardware accelerated, so we have really great performance. For those of you earlier that said, hey, we want to write games. Everything in IE 10 is hardware accelerated. We use the GPU for a lot of our graphics. If you go look, for example, in the store, everybody that installs it today, or go play with the hardware, install something like Cut the Rope or HMP. Right now, Cut the Rope with Septo Labs, which you all know, it's a native app in iOS. It's an HTML application on the Windows Store, and it runs fine. It's got good performance on ARM. It's got great performance on x86. So don't be afraid. Just immerse yourselves and go at it. Right. So I have very limited time, so I'm going to try to focus on things that are going to help you in the next 24 hours. If you win, I get one of those 6 surfaces because I'm part of your team. I'm coaching you here, so I'll be the coach. So I'm going to just talk about 3 things that are really, really important. I'm going to be around all the time, so any sessions, anything that I talk about, we can create a little group session or whatever, so feel free to reach out to me. I'll probably be wearing these green T-shirts because I get cold a lot. So I'll have that green sweatshirt, or I'll have the Yoda shirt. And I put my picture on the slide so you could find me later if you need to. But anyway, 3 things that I want you to remember. The first one is straightforward. Apps are not websites. Second one, I'm going to talk about confidence and context. And then I'm going to tell you a little bit about our libraries. And so let's walk through those 3 things. You're going to be building Windows Store apps. All of you are web developers. If you look at web developers, you have a very specific navigation model. You go from one page to another. Most of you at some point, I'm sure, has written something that was kind of an app, like using PhoneGap or something, and you know that the navigation model changes a little bit, right? That's pretty standard stuff. All this stuff you guys know, like, hey, there'll be a lift for navigation. There will be a different application model. You have to worry about, when your application gets launched and when your application gets suspended or people switch to another app. We'll get into deep dives for this as we go throughout the next 24 hours. The nice thing about it is you're going to get a lot of OS integration. I'm going to show you capabilities that you're going to be like, hey, that's a pretty cool feature, right? Kathy showed you share and contracts and search and all these really cool things that you'll be able to take advantage from within your HTML app. Right? Now, with us giving you all these extra integrations, we also have to give you a little bit higher level of trust. And that's where we've done a few things to tweak the platform such that when we trust you to do things, the user still has this really high confidence that your app's going to be okay. Right? Our goal with the Windows Store is to make a lot of money. We make a lot of money because we get a little bit cut of what you sell. So if we want you to sell a lot of apps, we want to make sure that a lot of users install your apps so that everybody feels like, hey, I can go in and click on install, and this app is not going to delete my files or do anything, evil. Right? So that's why we've done this, few changes into the application model such that you get this high user confidence. And here's kind of what the changes look like. Today, you're writing code in a browser. You can read IE or replace that with any browser there. And the way I look at it, and I'm going to use this term web context, which is where you're running, where you're in the browser. It's the sandbox, right? You write code, you're in a browser, you have a sandbox. That's where you're at today. Now, in the Windows Store app model, slightly different. You're writing code. First of all, it's in a different host. Even though you're using HTML and JavaScript, it's a different host. That's a different process name. The process name is wwahost.exe. Don't worry about it. That's just an implementation detail. You'll never have to see it. Right? Now, with this new different host, you actually have something we call local context. Right? So you have something different than the web context. And the reason why local context is interesting is that when you have local context, you have higher trust. And you can call these WinRT APIs. These are all the Windows 8 APIs that we use for applications that are in the Windows Store. And then these APIs give you access to all of the underlying OS integration stuff, like user data, so you can get to a user file system, their documents, all their stuff, right? You can get to sensors, you can get to, tiles, notifications, share, all this contract stuff are happening when you're running in that local context, right? So that's how you want to write your apps. Now, for those of you that need to integrate, let's say you're writing a Facebook app and you need to link to, a page or something that's like a Wall Street Journal article that's on the web. Right? We still give you the ability from within your app to bring an iframe. And when you bring an iframe into your app from within your app, right, and that iframe comes from a different place, something that's not local, we just give you the web context, inside your Windows Store app. Right? So we have two different contexts, and that's that's one of the few things that's changing with regards to the host. For you, it won't matter too much. You'll still be coding HTML, JavaScript. You'll just know, oh, my JavaScript is local as opposed to coming from the web. And again, you can mix and match as you want. So far, makes sense? Right? So if I was to summarize that one, here's kind of how I draw that one so that we make sure and we can dive into the next thing, right? You got to know that it's two hosts. That's pretty straightforward. It's an implementation detail you don't have to worry about. The next one that you have to be aware of is that there's two contexts. This one is more interesting, especially as you think about, hey, how am I going to integrate with Facebook? How am I going to integrate with my existing website and all the other stuff? And let me tell you the details behind those two so you kind of understand a little bit more. With regards to host differences, and let me just go here and show you this page. It's easier. Here's the host differences besides the different process that you're looking at. Right? Sorry, with the rush to get in here, as soon as Kathy was done, I didn't open this website. But you get the PowerPoint, and the main thing I want you to do is to go in, look at this API. This is going to be very straightforward. These are APIs that you're familiar with from the web, right? From your HTML applications or from your web apps that are slightly different when you're running inside a Windows Store, right? And there's two that are interesting out of here. The first one is if you scroll down to the bottom, a lot of the window APIs are not supported. The reason for it is because you're running inside a local host, you have a different navigation model, so we just don't have all the Windows stuff that the browser would have. Not a big deal. Most of those you're not going to need, or you have plenty of workarounds. The other one that's interesting for you is this. Because we want to be very high confidence, we want to make sure that you don't do something that can damage the system, we added a little bit of filtering onto the APIs. So if you use a property like inner HTML, right, we actually do a little bit of filtering such that you don't inject script coming from the web onto your application. right? This is where you're running local context. If you want to inject script, you can still do it when you're running on web context. So there will be a workaround for you, and then you can pass messages back and forth between your iframe and your application, right? But by default, this is something you need to be aware of. We kind of start filtering stuff, and all this does is, if I said something like inner HTML equals, and I give it a script tag, right? Or I do something that would be equivalent to script, the API will automatically filter it, and that's just going to throw an exception. Right? If you're not using it, you won't see it. Most of the time you don't see it. If you do see it, you'll see the exception. Come and ask us and give you the workaround. There's very straightforward workarounds for you to do the right things without having to worry about this. Go ahead.
I'm still not sure what the difference between the local context and the web context is. Can you show like example, like in terms of UI?
Yep.
How would it look different
if
I use web context?
Give me 2 more slides, and then if you're not clear, then we'll ask me at the end and we'll get through it. So there's no visual difference. That's the interesting thing that you have to look at, right? Or there wouldn't be any visual difference other than if you're using an iframe to include something. So give me 2 more slides and then I'll walk you through it, right? So for now, this is just the host difference. We haven't gotten to the differences between what you can do with local context over web context, right? So right now, when you think about what are the host differences, the 2 that I would highlight is some of the window APIs don't work. You'll see the list and you'll be able to skip them, no problem. And the other one is we're doing this extra filtering where you're setting specific properties like inner HTML. We're doing filters such that you don't inject script or anything that can be damaging onto your app. This is going to be simple. You're going to run into an exception. 99% of your code won't even see this, right? Or in most cases, 100% of your code doesn't see it. So you'll be okay.
Quick question. This applies to Windows 8 phone. So the question is, does this apply to Windows 8 phone? Windows Phone 8 does not have the same application model for HTML. Windows Phone 8 shares the SAML, or shares a lot of the SAML application model, and they share the WinRT application model when you're using like C++ and games. But Windows Phone 8 does not have a platform where you can use HTML. With Windows Phone 8, you're doing something very similar to what you're doing with iOS today, or with Windows Phone, where you're putting what we call a web view, and then you're just using your HTML from there and using PhoneGap or Sencha or some other framework out there to do some of this integration. Local context and web context is Windows 8 specific, yes. Only for Windows Store apps. So, right. And again, for most of you, you're just going to, you'll see me in a minute when I do file new project. You're just going to do file new project. You'll start adding your JavaScript, and you're going to be running in local context, and you'll never know anything, or you'll never see anything different. You'll see when I write my app, that's what you're going to do, and it's going to be seamless. It's going to feel natural, right? I'm just giving you all of that so that when you think about integrating with your existing website, or when you think about how am I going to reuse my existing code, those are the limitations that you'll have to, or those are the changes that you have to be aware of. They're not limitations as much as they're changes. Go ahead.
Do you have any really cool, unique API on your WinRT API, which is very different than Android and iOS, that we can take advantage of?
Yeah, I would say I'll show you some in a minute. Like for example, use our share contracts. That's very unique. No other platform has the exact same thing as share. We have a lot of really great APIs. Our notification API can run local, so we have a lot of flexibility within those APIs. We have, for example, when you look at search, in our platform with about 3 lines of code, you can make your application searchable from anywhere in the system. If you saw it with Kathy, for example, and I'll show you this application later, but let's say I'm right here. This is Windows, right? And I want to search for something like, a Mexican recipe, or something that has salt. This is the search within Windows, and you see all these applications that now I can search into directly without doing anything. So for example, if I'm going to look for a recipe, I'm trying to think what recipe. Let's just do ME and something will come up. If I want to search for a recipe, I can just go click and I'll launch this application that you're going to see code for, and it gives you all those recipes. It gives you all this functionality, right? That's pretty unique. I think that's unique within our platform, where you can search, from within the shell, right? I can search from within my app too. If I launch the application and I do search, that will work from within the app. But the ability to do it from within the operating system is unique to us. So there's a few APIs like that.
Earlier that you can run 2 apps at the same time.
Yep.
But what is the maximum of apps that you can open up at the same time? For example, maybe I open a dating app, but my
Yep.
How can I do
Yep.
multiple app mashup?
That's a great question. So our application model is, if you're familiar with iOS or like our application model is very similar to that, where first of all applications kind of run within their sandbox. So applications don't communicate with each other unless they have contracts. Usually they communicate through contracts. Now we have a lot of contracts. For example, share, search. We have protocol handlers where we launch from one application to another, passing parameters and stuff like that. So there's sandbox within that. That's the first question, just to so you can think about it as that way. With regards to how many applications you have, the model for us is pretty straightforward. For example, right here, if I click right here and right now I have Internet Explorer running. That's what we call the foreground app, right? So there's one application running there, right? Now that's one Windows Store app. That's the default. Most of the time, that's what's going to happen, right? If I, for example, right here, go ahead and press this and put it on the side, I can come back here and launch another Windows Store app. So let's see I'm looking for something. This is my demo machine. So let's say I launch Kayak. You saw that earlier. So now both of them are running together, right? That's from a pure Windows Store app, from a pure Windows Store standpoint, you have two running together. That's right now, both of them have CPU, both of them have resources. Now, if I launch another app, the third app, right? Let's go back here to Windows and find yet another one, like the Store app, right? So this is my third one. So you have to look at, hey, how many are running now? Here's what happened. First of all, this one right here, my Internet Explorer, still running. It's still in the foreground, right? So at any one time, I can have at most two on the foreground. Now, the other app that I launched, now I don't remember, it was Kayak, is still in memory, right? But it's not getting any CPU cycles. So if that app was doing something like, monitoring, like Endomondo monitoring GPS or something like that, it would not be getting events. It would not be firing events because the app is in memory, but is not in the foreground, right? We do have background processing. We can talk about those as you go for specific needs on the app. But the default model is that app right now is in what we call suspended state, right? Now, for me to bring that back into memory, all I got to do is, for example, here, I go back and I just flick, or the user presses Alt-Tab. That's the kind of the task switching that we do in Windows, and the app comes back immediately. So to the user, it feels like they have 25 apps running at any one time, right? The reality is 2 are on the foreground, 2 are getting CPU cycles, and Windows is doing all the application management for you. iOS, Windows Phone, a lot of platforms have very similar models. What's unique to us is that we do have the snap, so that does give you 2 on the foreground. So
So in iOS, they limit on how many things you can do and type of thing you can do on the background.
Yep.
Do you have limitations? Like how much I can do on the background?
yeah, we have different models in the background. We have we have a very different model. I think it's richer, more flexible in some cases, but it's also, we definitely have what I would call, we definitely monitor and we definitely have some sort of throttling that we do with regards to how much you can do in the background. We have different models. That's why I'm kind of being bogus. For example, we have something we call real-time communications app. Those applications have a lot more resources. Like they can run every 15 minutes and they can constantly use that. That'll be something like my email or Skype or any application that maybe like a Twitter or even Facebook, something that's always running, and the user has control over how to configure those. So the user approves, hey, this can be what we call a lock screen app. Right? And so those get a little bit more benefits. And then we have other models where, for example, we have something called a maintenance trigger, where an application can just say, look, I'm the Wall Street Journal app, and all I need to do is once a night, I need to download the latest version of the journal. And at that point, we're like, hey, as long as it's on power, we give you CPU, and you can go ahead and do it. So there's different models. They range anywhere from, the real-time model that I'm telling you about, to hey, the application runs every 2 hours when you're on battery, and they still get limited CPU, right? Our goal is to make sure that the foreground app is always the app that has most CPU and it's always responsive. So we have a very similar model to those, and I can walk you through every little detail if you need to. If you look me up or look any of the Microsoft guys, Craig, for example, would be good. So, yep. So for example, he or I can get into every little detail and tell you what your best configuration is. He does bring up a good point. We do have background transfer APIs. So if your application is more worried about, hey, I'm going to do, like I want to run in the background so I can transfer something. If I was running right here, like if this application was something else that was doing a background transfer, when you suspend, background transfers do continue. So we have APIs that you can use such that if your application is suspended, the background transfer can still continue. You can manage your queue when you get resume and everything else. So you'll get a lot of that.
How open or deep down you open your camera API?
How deep down we open it as deep as you want to go. We go, and I can show you a demo. We give you a very high-level API that says, hey, you want to capture a picture here with one line of code. You just get the standard Windows UI. And you can do it. So for example,
I'm talking about like,
yep.
camera filter, like
Yep.
Instagram, that kind of.
Yep. So we do both. So for example, right here, like if I go here and I'm just saying, hey, brag a picture, this right here is just going to immediately, I wrote one line of code and you get all of this integration where they can take a picture of me and everything else. I get the picture file. It automatically handles the camera, everything else. And we also have APIs where you can get down to the stream and actually apply filters onto the stream, manipulate the stream before you display it, save the stream, do a media extender, like kind of do extensions onto our media pipeline. You can do all of that. So we give you very rich access onto the media API.
So we can actually manipulate the image, right?
Yes. You can manipulate the image that's coming through the camera and do whatever you want with it, save it on your own. We give you access to encode and decoder APIs too.
Okay.
So you can actually do that. Yep. You can, well, so from within JavaScript, there's two things you can do. Because I told you all JavaScript is a first-class language, right? So what you would do from within JavaScript is you can call onto both native components that are written in C++ and native code, or you can write your own. So if from within your JavaScript app, you can definitely write some C++ component that manipulates the stream and displays it back onto your JavaScript app and all that. Seamlessly, you can communicate from JavaScript to C++ or to C# and go back and forth as much as you want to.
Okay, I'm a little confused. So you are suggesting us to write C++ to do that?
He's asking us because like the performance of JavaScript, if you're actually manipulating a stream, right, you need pointers, you need down to the byte data, so that will likely not be great in JavaScript, and you couldn't even write the code such that the manipulation would be seamless. So yes, for that you would interrupt to a lower layer. It doesn't have to be C++. You can do C# if you prefer C#. But my point is, in our application model, you have JavaScript and you can communicate down to C# or to C++. All of our native platform, all of our WinRT APIs are written in C++. So they're native code that performs really well. And from JavaScript, you have unlimited access onto those APIs, as long as they're written such that they can be consumed as a WinRT component, which the rules are very simple. You can definitely go back and forth.
Do you allow us to use JavaScript to manipulate, the custom UI layer on the camera? Like, when you project, the camera, just like navigation,
Yep.
like background,
Yep.
all these
So,
things.
yeah, so from within JavaScript, you can get access to the whole stream, right? And then if you want to, override the transport controls and all that, you can do that. Yes, no problem.
JavaScript.
Yes, JavaScript.
It's just things like manipulating the video stream that's
Yep.
coming from the camera needs a C++ component that's written to work on the media foundation layer of Win32.
Yep.
You can't write that particular piece of code in JavaScript to make a custom filter.
And that just has to do with,
Get the camera feed.
yep. And that just has to do with how the media pipeline works, right? It doesn't have, if JavaScript could do it, and actually, well, we would have to make sure that we could load JavaScript into our pipeline. So at that level, you're down to C++, but you can do it. Like you can just write the C++ component. In fact, if you guys come to me afterwards, I'm going to show you. I keep showing you this demo because we have hands-on labs for a lot of stuff. So for example, I have a hands-on lab where you can open up an image, and then I show you all the code to do red eye, to fix red eye on pictures. So you have a JavaScript, a JavaScript app that opens up an image using the IMG, HTML element, and then we can get onto the stream and manipulate it and fix the red eye from C++. We have a lab for that, so you can just look at the code and reuse it if you need to. So I'm going to get back to it because otherwise I'm going to run very, very long. I do want to answer all your questions, so feel free to raise them as we go. But I want to make sure I get back to it to get back into theme, so I don't get too detracted from all of that.
Now I don't remember where I was at.
You were sharing, I think.
Yep. So let's go back to
Go
desktop.
back to your deck.
Yep. So I had just shown you all the difference between the host. Again, the two differences that you should be aware of. Actually, the higher level difference that you should be aware of. The first one is all of your window APIs from JavaScript. Some of them will not work. Go look at that list. It's there, right? And then the other one was if you use inner HTML or certain specific functions like document.write, things that manipulate the object model, the actual DOM for your HTML. We will actually filter them. And again, that's just meaning if you're actually setting something like setting it to a script, we will actually filter it and you get an error. Right? Again, most of the time, and you'll see me when I get down to a demo in a few minutes, you'll see that you can write in HTML to text and do the right things just like you do on the web today. It's just that we do the filtering, and this is just writing safer HTML. This is something that you can do on the browser today, and it's a better practice to do anyway, so a lot of people are doing it. The last host difference that I want to highlight is when you're writing in this Windows Store application, you're running inside these different hosts, we don't do plugins. So no Flash, no Silverlight. You would get those in the Internet Explorer browser. That's on the desktop. We don't do that. We don't do that on the Windows Store app. Now, even though there's host differences, I want to emphasize this is still the same JavaScript rendering engine and the JavaScript engine and the same rendering engine. So again, we go back to you are writing code that you're familiar with writing already. So you're not going to have anything new. It's still going to be very easy for you to actually do that. I underline it because that's really, really important for you to know that you can reuse your code, you have your skills, you can go ahead and do the right thing. This will explain a little bit of what happens between the two contexts and what's going on, right? So when I talk about there's two contexts when you're writing a Windows Store app, here's a little bit of what's going to happen so you kind of understand them better. First of all, we do have local context, and again, local context is the one that's running on higher trust. So from local context, you'll be able to access the Windows runtime. That's all of this functionality that I'm talking about. That's operating system integration. So you're running outside of the browser sandbox. That's what it means, right? You can access Win.js, which I'm going to tell you about. It's just a JavaScript library. And you can do cross-domain XML, HTTP requests, no problem, from within local context. So this is kind of a little bit of, hey, these are the things that you could do. And again, for you to think about what is local context, it's very straightforward. If you ship the JavaScript in your app, right, and you run it by default, that's all running local context. That's all going to have the benefit of this. Right? This is 99% of the time how people write apps because your app needs to work offline, your app needs to be able to work when disconnected. All these things are things that you would want to do if you were writing but it's a kind of Windows Store app or a Windows app, right? Now, web context, here's the differences, right? If you're running in web context, this is like, again, imagine that I'm writing a Facebook app and I need to bring an iframe from, say, Wall Street Journal, right, or from eBay or something like that. Something that you don't control, something that you don't want to tweak because it already exists, right? Just is the same than bringing an iframe onto your application, right? And that iframe is going to run into, on the sandbox as it does in the browser, or a similar browser, similar sandbox to what you have on the browser. So the first one is you cannot access the Windows runtime, right? If you have local context and web context in one app, you can communicate back and forth, posting messages back and forth. Right, the standard post message API that we have with HTML5, so you can communicate back and forth between them, right? But from within the web context, you're not allowed to access the Windows runtime. You're not allowed to run in the Windows library. Some of it works, but let's just say that it doesn't work since it doesn't fully work. And then when web context, you can link to scripts that are outside, right? So for example, if you write Facebook apps, right? Most of us that write Facebook apps, when I write a Canvas app, I link to all.js, which comes from the Facebook CDN, right? That would automatically, if you try to include all.js from the Facebook CDN, that would automatically put you on the web context. You would have to be working on the web context. When I show you my examples on how to write Facebook apps today, I'm going to use XML HTTP requests for everything. So I'm going to use the Open Graph APIs, and I'm going to use XHR, and that will run on local context, and it gives you the better, it gives you all the goodness of WinRT, and it gives you access to everything in Facebook, as Bear showed you earlier. With Open Graph, you can get to a lot of stuff. So that's kind of how we're going to do it. Go ahead.
So it's kind of confusing, like you said, because if you're making a Facebook app, and if you're doing AJAX request cross-domain, you cannot do that in web context?
if you're looking, yep. So if you're writing on local context, you'll be able to do it on, no problem. The XHR will work no problem, right? If you're writing on web context, right, then no, cross-domain will be blocked, right? But again, if you're running on local context, and that's where you would use XHR, because if you're not running on web context, there's a lot of other things. You would be going to an existing website that might already have the Facebook functionality, like the, like plugin from the web or anything like that. So from this side, if you're running in the local context, you won't have an XHR problem. Again, I'll show you a sample in I think it's probably one or two more slides.
But if either of these contexts, you can still access the native, the WinRT API?
Yep, not from the web context. So from the web context, you cannot access WinRT. That's the big difference, right? Again, most of you, if you leave this room right now, you go back and you start thinking about your app. Think about you're writing an app, not a website. That was the first point that I highlighted, right? So when you're writing an app, you're going to want to be disconnected. You want to work, while you're offline. You're going to be wanting to do all these things that are slightly different from your web, right? So you're going to be, by default, you're going to land really well in local context, and you're going to be in really good shape. I'll show you an app in a minute that is a pretty complete app that you're going to have source code that's using local context, integrating with Facebook and everything else, and you're going to be like, hey, I feel like I'm in pretty good shape. Or at least I hope you feel that way. If you don't, then we'll talk and I'll fix it throughout the next 24 hours so we can write something cool. But if you're on web context, this is the model that we would use here is, for example, if you want to reuse something that you don't own, right? Or if you have an application and you want to just integrate some of your web app, some of your HTML app onto a Windows Store app. Right? Like let's say I was eBay and I want to do the shopping catalog within the Windows Store app, but then when the user decides to check out, I'll be like, hey, I'm not going to rewrite all my checkout functionality just yet. It might take me 3 months to do that. So you can just launch them onto the web context and check them out there. Right? Yeah, you can mix and match, post messages back and forth. Right? Remember, that's two contexts within the local store app, no problem.
And user cannot tell the difference.
Yeah, the user cannot. It'll be seamless to them. So.
Can I make a note about window.close there, even though it works in the local context to shut the app down? Windows Store app should not have a close affordance anywhere in the UI because we have standard gestures for that.
Yep.
If you add a close affordance, you will fail store certification.
Yep.
And even though window close works, there's another API called msapp.terminate app, which gives you much better analytics and crash dump reports in the store. If you need to terminate the app for some reason, that's the API you should use.
Yep. And so I think I would reword that as your app, unless your application, your app should never exit on its own. Let the user shut it off. So window.close would actually shut down your app if you call it. And it's, it's okay to, it's available there, but you should never do that, right? Same thing for MS app exec, where you shut down your app. The only reason there is if, for example, a licensing is invalid or something like that you're thinking that you shouldn't be doing, because we monitor all those things and we'll come back to you with hey, what's going on here, right? And you can fail certification if you do it, such that when we go to certification, we think, you shut down your application and we think it crashed. We'll be like, oh, because we won't know the difference, right? You shut it down, we think it crashed, you'll fail certification. So just, I would never close your app, but the API is there. I copied this from the docs, so I did edit it a little bit, but I didn't want to take out all the ones. And by the way, this is a subset of the list. These are the ones that I think are more relevant. I gave you a link to the full one, so you can go see the difference. But these are the ones that really matter. These are the ones that you'll need to be aware of, right? So you'll be okay if you just follow these. All right, cool. Last, 2 more slides and then I'll get to code. I know I'm running slow, but I think we have a good Q&A, so hopefully you're not falling asleep yet. Win.js is the new framework, or one of the new frameworks that we have for Windows applications. And let me tell you where you're coming from. So just show of hands, how many of you are like jQuery guys? That you use jQuery a lot? Something else like YUI or anything like that? Right, so most people have their own little framework that they use all the time. Right, and all of those you can still use as long as you have an API or you have a library that's compatible with the restrictions I told you earlier, like inner HTML and the web context versus local context. You'll be fine. For example, I'm one of the guys that does the jQuery stuff. So I know that we have, like on on GitHub, we have a version of jQuery that works, that's supported, that you can use if you want to, and it all works within the local context model, and it has all the proper safety such that the user has the right high trust. So if you have a preferred library, you should be able to go ahead and reuse it. But what happened to us with WinJS was this. As we were thinking about the new platform, right, Microsoft was going to also write a lot of HTML apps, and we thought, we have this thing that we call the Windows personality, right? Kathy talked about our design principles like fast and fluid, right, and authentically digital, and all these things that we have. And so we said, look, there's going to be a lot of controls that are very specific to Windows. Like, for example, we have a list view, or we have a control that, if you have a list view, we have this thing called semantic zoom, which I think Kathy showed. And if not, I'll show you in a minute what a semantic zoom. So we have a lot of controls that are very specific to Windows, like an app bar. Right? So what we said is like, oh, you know what? We want everybody's applications to be consistent. When somebody uses the app bar, we want to make sure that whether they're using an HTML app or a SAML app, or whether they're, it's published by two different people, that the app bar is always the same. So we said, oh, let's go in there and write a Windows library for JavaScript. Right? Very much like the SAML guys. In the next session, you're going to hear, hey, we have all the SAML controls, and we have standard implementations that you can reuse. Right, such that you're consistent with Windows, such that you can get the Windows personality by writing a lot less code. Right? So that's where we started. We started, hey, let's go in and write a Windows library for JavaScript. And then our goal was to write the controls. But then we said, oh, you know what? Well, we have to do styling, right? And we have to do animations. And then people started saying, oh, you know what? We got to give them data binding. Right? So we started kind of like adding up, and we ended up with this WinJS thing that is now kind of a collection of toolkits. It's more than one thing, right? This is what WinJS is to you, right? So, and you'll have a reference to all these later, and we're going to walk you through a lot of it. So you see here, for example, these are the platform controls toolkit. Here are the Windows personality control. Here's the really hard ones like flyout and list view and app bar. These are the ones that are going to save you tons and tons of code. So you want to use this, right? And you'll see in a minute when I code one of these, you're going to see that they're very, very straightforward to use, right? And then because we had to do all of these, then we said, oh, for example, let's give them data binding. So you will have data binding with that. And you can use all of this. You can mix and match. For example, again, I'm a jQuery guy, so I do a lot of jQuery, and I use WinJS together, and we go back and forth, and it's seamless. It's all JavaScript. Right, so very much like today, you go in there and download either jQuery and then download handlebars and download all kinds of different frameworks or plugins to make your application work. You can do the exact same thing with our stuff. You can mix and match between WinJS and your favorite libraries, your favorite code, and everything will work fine as long as you're using standards-based JavaScript.
Question.
Go ahead.
Are these in JavaScript?
Yes.
They're like modules.
These are modules. It's one library.
We need to import them.
Yes.
Before we need to use it.
Yep, so the question is, do we need to import it? Yes, I'll show you in a minute how it works. The library ships, you get access to all the source code. It's all standards-based JavaScript. We give you the source. It's not even minimized because the way our platform works, we don't need to minimize code because we use byte order when we load the applications. So we're fast already. We're kind of like pre-cache with regards to byte order when we install your applications.
JavaScript manifest as to the dependency.
Yep, and all of that happens through the tools automatically. So, go ahead.
This WinJS, like, is it available outside of? Because it seems like a cool library. You guys have done a lot of work. Like,
Yep.
just if I want to make a web app, can I use this?
So so when you like if you have the tools, you get access to the whole source code. We're not supporting it on the web. We know that it the way I would put it is 80% works. So I would tell you, hey, I wouldn't advise that you use it. If you try, there's lots of people who have made it work on the web. But honestly, it's really designed for Windows Store app. It has a lot of functionality that is very specific to Windows Store. For example, like when you get down to like all of this stuff right here with the application model and navigation and certain things, there's things in there that are really, really designed for Windows Store. So I wouldn't recommend you go there. But if you want to, you have the source. And as long as you're willing to live in kind of a unsupported world, you could reuse some of the source if you want.
I'll do the follow-up.
So-
Is like, so I understand that you guys have like kind of like some kind of like UI or UX like with the animations and the CSS like guidelines.
Mhm.
So these are like custom, like already pre-made for you. But if I want to be different, can I change those like gestures, how they behave, and add my own like animation. Is that like how strict are the like the guidelines for
Yep.
you to do stuff like that?
Yep. So we have, very strict, but we have concise and well-defined guidelines that we would encourage you to follow. With regards to like, hey, for example, like again, if you decide, hey, I want to use jQuery animation, you can use jQuery animation as much as you want, and as long as you're using the APIs that are within WinRT, which all of the, anything that's JavaScript will be fine, right? And as long as your application is not crashing, and is not hanging, it'll be fine. You'll pass certification. Certification does not enforce like, oh, what library are they using, or oh, how long did that animation take? Certification does enforce certain things like, is there settings page, or they have a privacy policy, and certain things where there's a synergy between how you write your app and what it looks like, right? Mostly settings is the one that I could think of that you would have to watch out for. But everything else, you'll see that you can write your own animation and be fine.
The
Right.
animations library is just written in CSS.
Yep.
It's just CSS transforms and opacity animations
Yep.
and stuff, so you
And-
can see exactly how they're written.
Yep.
Even has an API that lets you build your own animation easier than just doing it in raw CSS.
Yep.
So there's no magic going on. There's just the standard Windows 8 personality implemented in that library. So if you want the fade-ins and the fade-outs and the way the tiles work and that, it's all there. You don't have to figure that out or reverse engineer it.
And you can also write your own. Like I have applications that have, when I use, for example, like, pop-up animations and stuff like standard gestures or standard things that are on Windows, like how something appears, how something fades, how a page comes in or transitions in or transitions out. I use the standard ones. And then, I go crazy where I do 3D things flying around because we have CSS, with 3D transforms. I go crazy and I do some cool stuff within my app, and all of that is fine, right? You have hardware accelerated CSS with IE10, and you have JavaScript, and they're very performant. There's a lot that you can do. There's some really cool apps. Again, think about all the games. That's all they're doing, right? They're just manipulating stuff on their own. It's all custom. So, go ahead.
The implementation is pure HTML5.
The implementation.
No filters, no more
No.
stuff-specific
Ex-
filters.
That's right. The implementation, that's really, so it's all standards based, right? The only thing that we have that's actually beyond, or I would say is not standards based, is we have a very rich touch API. It's called Pointer. It's our Pointer API. And it's really, really cool because what our Pointer API does is it allows you to code to an API, an input API that automatically aggregates pen, mouse, and touch. So when you write your application, you can write to this Pointer API and you can write the pointer down, right? And that will be the equivalent of the user either clicking with a mouse in in that spot, or the equivalent of the user actually tapping with their finger or using a pen, right? And we've already submitted the Pointer API back onto the W3C as a recommendation, and they're considering. So I expect that that's a direction to touch, and we will always make sure that we're implementing their specification. But right now, because we needed a richer API, we did get a little bit ahead, and that's one of the few that you have that's extra. The other thing, to go back to your point, that we have that you're going to see a little bit of are, for example, there's areas where HTML5 has an API, right? There's a standard, for example, geolocation, right? That's a web standard already. And we have geolocation. We implement it exactly to the spec. But we also have WinRT location APIs that give you more functionality. And you can choose which one you use, right?
That's the same?
Performance is the same. Underneath, they're even using the same location stuff. So you're not, if you use both in parallel, you're not doing twice as much work, etc. But yeah, you can decide which one you want to use. So there's some overlap, but we do have the HTML5 ones there for you to use.
Your layout implementation is heavily using the CSS grid, right?
Yep.
Which WebKit does not support yet.
That's right. So our layout implementation, again, we got a little bit, but that one, grid and Flexbox, those are coming. For example, Firefox has slightly better support. Those are standard implementations that are already farther along. So it just comes down to where the browsers are.
It's not the public version.
Yep. So he's right. So we do have, again, maybe and I highlighted Pointer because Pointer is a little bit farther, but we do have other APIs. And again, this goes back to with IE10, we cut up and we leap forward. We have things like Flexbox, Grid.
which are going to be very useful to you when you write a Windows Store app, because you want a Windows Store app that can run on any resolution. Maybe you have a tablet like Kathy showed you, which was 1366 by 768, or you have my laptop, which is 1920 by 1200. So you want to make sure that you have these dynamic layouts, and these layouts controls will help you do that. Now, if you choose to not use them, that's fine. You can go in there and do divs and do CSS and floats and everything else, but you would have to do it yourself. So that's where, that's the trade-off between how much you use from the platform and how much you're not. The beauty of this thing is that you're guaranteed, when you run a Windows Store app, you know exactly what your browser is, right? So you're guaranteed that there's only one platform there, there's only one API, so anything you code to that API, you don't have to go back and cross or test on a different browser, because for us, whether it's running inside our ARM, the Windows Surface devices, right? The Windows RT devices that, like for example, our Surface or any other Windows RT device, whether it's running on Windows RT or whether running on Windows on x86, the API will behave the same, right? If you're using the HTML APIs, you'll be there. So you don't have to worry about, I got to go test everything twice or anything like that. So that's where you're at, and that's the trade-off you have to make. Again, it's a well-known platform, so I would say write the least code, because it's code that you end up throwing away later when, for example, WebKit catches up and they implement Grid.
So on iOS, there's like 5 different audio API, and like the higher level is like system audio. They limit on how long you can play, system sound. Do you have how many audio APIs you have, and how any, like really big, like limitation?
So we probably have, like, I don't know if I can count them, but depending on how you count them, we probably have more than 5 APIs. We have the standard audio tag that HTML5 uses, if you're using HTML, and then we have other audio APIs, lower level stuff that you can use. For example, if you're writing a game in DirectX or something like that, we have lower level APIs that you could use. To go back to your example earlier about, hey, how can I capture audio and manipulate it? Right, we have lower level APIs that will let you do that, like control pitch and all kinds of stuff. So I don't know if I would say, like, it's probably not that far from 5. I don't know, like, all the limitations in iOS, but I can tell you that on our side, we have a platform that's very rich, so you just got to pick the right API and go do the right thing. Our audio platform is designed to support HTML at the highest level, all the way down to really advanced gaming and really advanced, really intensive audio manipulation. So you should find the right API, like you should have the right API available to you. So, but you might have to learn more than one. Go ahead.
So if I do need to write a C++ routine, how do I call it from JavaScript?
What's the connection? Yep. So when you write a C++ routine or a C++ component, and I'm not going to go into it here, but you just follow specific rules. You go in there, say file, new library, and you follow some specific rules with how you define your class in C++. Right? And then from JavaScript, it's seamless. In fact, in a minute, when I show you how to code some JavaScript APIs, I'll highlight a few that I'm telling you, hey, these are actually C++ APIs, and you'll be like, that doesn't look like C++. And it's just how they're implemented. From JavaScript, we have this thing called, we have this binary, abstraction, where like you're coding in JavaScript and you're actually, coding down to C++ or native APIs, and the syntax and everything looks to you like it's JavaScript. Right? And we do those same projections of our native APIs onto C#. So for example, for those of you, if you want to see a cool demo later, I can show you like the exact same, like how you can call the exact same API from C# and from JavaScript. And it's just like the syntax changes just a tiny bit, because for example, like JavaScript people like to do, lowercase for methods, right? C# people like to do uppercase. So the actual implementation, the projection of the language takes care of that such that it feels very familiar to you, right? So I'll show you some and you'll see like, wow, that doesn't look like C++ at all. So I think that's it, actually. I think we're going to get to code now. So I know I'm running behind, so somebody tell me if we need to give them a break or anything like that. But let's get through and let's get you into the platform and see what these would look like. Yes, all of this stuff, and I'll show you later. I'm going to show you everything. I'm going to show you all the code, all the samples, everything. These slides are going to be online. We have a SkyDrop, so you can just access it online. The link will be at the end of the presentation, and then it's going to be easy enough to remember. And you can download all that and get started, or come and look me up, and we'll get you started. So, All right, so I'm going to show you these, and I'm going to, normally, in fact, I intended to code the whole thing. This is going to be about 50 lines of code, and I was going to code it all on stage, but because we're behind, I'm just going to show you the one that I already coded, and then, we'll take it apart, so as we go. Yep, give me 1 second. I'm going to open a new one. Yep. So, sorry about these. We changed something so that we could capture the screen. And, in between I did a reboot. And so hopefully you guys can read this. And let me go back to this other version of Visual Studio and do the same. So, yeah, so it's there. You're good. So cool. So this is Visual Studio. To code a Windows Store app, you will need to code it on Windows, and you will use Visual Studio. So even though you're using HTML and JavaScript, and you could code it on Notepad, you will need to use Visual Studio to package things and to make everything. It'll make your life a little easier. Visual Studio is very powerful with regards to like IntelliSense and catching little bugs. We have a really great we call it DOM Explorer, which is like the equivalent of F12 tools. That everybody uses in the browser, so you can debug and stuff like that. We have all of that, so it's kind of something you do want to use. But you will be running on Windows, and you'll be using Visual Studio. For those of you here in the room who don't have Windows today, when you go back there, they will give you a license of Windows, and you can run it however you want using Parallels or VMware, VirtualBox, whatever your flavor of virtualization is. We'll hook you up in the back, and you'll be able to do this. So, okay. So I'm just going to show you a default file new project so you kind of have an idea what this looks like. So I'm just going to go and say right here, say file new project. I'm going to give you a complicated one, and then we'll take it apart a little bit at a time, and then we'll go in and write some code. So I'm going to go here, and you see like we have templates. So these are application templates. You can start with a blank app or a grid app, or the grid app is one that has a lot of functionality already canned for you on layouts. So I'm going to show you that one. But you can begin with anything, something smaller or something big, depending on what you do. I highly recommend you try all of them, or you ask me like when you're designing your app, and we'll tell you what might be a good way for you to get jump started. Right? So I just go back here, and I just did a new project, and let me show you what this created. So you kind of have an idea of what happened within your app and everything else. So he created this project, right? And the project has all the files that we have. And we have, for example, an application manifest. This is where you enter the metadata for your applications. You're going to enter capabilities, and you're going to enter contracts and things that you implement. So this is just an XML file. We have a UI right here. But for example, if you want to edit it as an XML file, you can come back here and see what it looks like. And it's just an XML file that has, your manifest and, everything, files and things that are included and capabilities and certain things within your app are going to be there. Now, that's one thing that it generated. It also generated this thing called a reference. And right now, the only thing you can add a reference to is the WinJS library. So the project, by default, already includes kind of a reference to your WinJS library. So to go back to whoever asked earlier, here's how the library gets included. If you go look here from the default HTML, we use a standard link and standard script tags to include WinJS. So this is how we include WinJS in your project. And again, the default template will do all this stuff for you, so you don't have to worry about much of this stuff, right? But that's how we include WinJS. If you want to go look at the source for WinJS, it's right here under the references. You can open it up, and you see all the CSS. The CSS is there because we have Windows themes. We have, kind of a look and feel to give you the Windows personality for your controls. So for example, even though you're using an HTML like button tag, right? We still have a look and feel, a CSS that looks, that makes it look like a Windows button. They're square, they're, dark or light and all that stuff. So we give you all that CSS. You can tweak this one, but I don't recommend you tweak this one. I think just write your own CSS and override it. Right? That's the standard way we would do it. So, standard practices apply. And then if you want to go look at a JavaScript, we have the exact same thing. So I can go back here. Our JavaScript is kind of, in two files. Base.js is what I call the foundation. Here's where you have a lot of, the utilities and things like that. And then UI.js is where you see a lot of the controls. Again, it ships the source. You can go look at it. It's all JavaScript. We didn't cheat at all. Right? So you can go look, you can play with it, and just include them and use them. Wow. All right.
You said you don't recommend like tweaking,
Don't tweak it. Yeah.
We definitely don't recommend you tweak it. If you want to override CSS or you want to customize the behavior, just subclass it or override it through CSS.
Is that minified?
It's not minified.
You mean it's readable?
It's readable, yeah. So you look right here. I'm opening it up. In fact, we ship it unminified.
I thought Studio account put the format.
No. Visual Studio doesn't minify it at all. We let you do it.
When it loaded to the application, is it minified?
When you load it in the application, when you ship it in your application, which actually, technically, when you do it as you add as a reference, you don't even ship it, right? Because we don't even want to pay the overhead of downloading it for you. It's already in the system, right? The system has it for you, or the system will download it once and share it for all the libraries that use it according to the same version. So if you ship version 1.0 and somebody later on ships version 1.1, we will have 1.0 and 1.1 in the framework, and then 50 applications can share it. And it actually doesn't ship minimized because we use this thing called byte order mark.
It's integrated to the.
Yep, it goes with the OS. Yes. Yep. So this is already in the system waiting for you, and you just reference the library, and we automatically have it for you there ready. Right. If you modify this one, then don't include it the same way. So actually go in there and don't add the references the way we do it.
My question is, in my local system, can I just modify some of the libraries that will work for all these applications? If you modify the code here, don't include it as a reference. You have to copy the files and include them as if they were your own files, because otherwise we're going to download it as a reference and we'll override your changes. I'm not asking developer perspective, I'm asking in terms of user perspective.
Oh, from a user perspective, can you change the settings? No. For the most part, no. Yeah, actually, no. Let's just say no. The user does not have control over what an animation, how long an animation takes, or anything like that. So that's where we're at. Cool. So that's the default project. This is what's included in it. Let me just run this one so you can see it, and I'm going to show you this one thing real quick. This is just our simulator. Now, when you debug, we have really great debugging support. You can put breakpoints. You can see everything in here. And you can either debug against local machine, so you just full screen, you'll get an applications like this. Or you can run it against the simulator, and I'm telling you both so that as you go back to your desk and you start coding today, you can try both. So this is the application. This is the default project that we created. You see, for example, navigation's already there. You see a lot of stuff that is pre-populated. You could just override the data or start hacking away and replace the things, and you'll have a working app, right? I can also do this from within the simulator, right? Oops. Right. So I can just come back here and say debug, stop debugging, and actually just run it from within my simulator. And then these will run inside the simulator. And a few reasons why you want to run inside the simulator. Our simulator simulates touch, right? So for example, if you don't have a touch machine, but you want to try a little bit of, hey, how would this panning look, etc., you can use your simulator and simulate touch. Another thing that the simulator can do is, for example, changing orientation. So if I click right here, change orientation. All of the events that would happen if orientation had changed and everything else are happening underneath. And you see the application redo its thing and everything else. So it gives you a little bit of access to that. The last thing that the simulator can do is actually change resolution. So you can go back here and say, hey, I want this application to look, or I want to see what my application look like at 1920 resolution. And somehow this one's wrong. I'm running Camtasia underneath so they could record it. So you see that it's changing as we go. But the simulator will let you do that. So it's something worth trying. Another thing that's if you only have one display, debugging so you can see your Visual Studio Code and what's running in the simulator together is much easier to do this way because our applications are all run full screen. So otherwise you're going to be having this really weird back and forth. So consider a simulator if you have that. But I think for the hackathon we have an extra monitor. So you'll be okay. So.
Simulate touch.
Yep.
And, rotate with
Yep.
a mouse.
Yeah. So we give you. Sorry.
Simulate with a mouse.
Yeah. So with mouse you can simulate touch interfaces like gesture, like zoom in, zoom out. Yep. You can press down the control and then zoom in and zoom out. And then we give you the ability to stretch it out with mouse. So we have a lot of that.
Documentation.
Yep. So, and I'm going to go quick because I want to get to the Facebook stuff, and they gave me a 15-minute sign over here. They've been asking me questions. That's not fair, right? You guys should say, hey.
Listening to you.
Yeah, you guys should say, can we get a little bit more than 15 minutes? All right. So.
I want everyone to get to the hacking so we can,
Yep. So let me get you to some of the Facebook APIs so you get an idea of coding things from scratch. So, and again, I was going to code this on stage, but to go quickly, I'm going to go like this. Let me walk you through it. So this is the exact same thing. I actually did a file new project, and I did an empty project, and you're going to get the source for this. So let's parse it out and see what's in there. So the first thing that I did is I just added an H1 for Facebook sample. That's my header. And then I added a bunch of buttons, a login button. This is where we're going to go in and log into Facebook. I want to show you that because that's important, right? You're going to get your token from there. Then I added a little bit of a, hey, get me button. So this is where it goes and gets my profile, so I get all my information, just to show you making a post request. And then I added a functionality to get my friends, such that I could show you at control. So let's walk through them one step at a time, and you'll see what we have for you. Right. So the first thing that we have for you that's going to be making your life very, very easy is this. Windows has this thing we call the Web Auth Broker. So if you know Facebook, you're going to use the Graph API or the Open Graph API, you're going to need to do auth. Right? And what we have is we've already implemented that for you. So we give you this thing called a Web Auth Broker, and again, you'll download this sample, and it'll be the same for your C# guys. And you pretty much just configure a few parameters here, like for example, my Facebook URL, my callback URL, and these are generic, so you can reuse these ones as I have them. You pass the scope for your, for your application, like say, hey, scope is read, and give me a response type token or whatever. And then you call onto this API. And for whoever asked earlier, remember you asked, hey, what does it look like when I call a C++ API? Let me go back. This is what it looks like when you call a C++ API. You're actually going back, and it looks to you like you're just calling something here. Like for example, these, right here, Windows.Foundation URI is a WinRT type, right? So I'm just saying, bar, declaring a bar the way I do in JavaScript, saying, hey, star URI equals, and then I'm calling a new C++ object. These are native objects, right? If you're looking at, hey, how do I make a method call? A couple lines below, you see it right here. You have Windows Security Authentication, Web Authentication, and you can actually declare short names for your namespaces if you want to. I did it as explicit as I could, such that you would have all the namespaces that you need, so you can hack on your own. Right? But this is calling onto a WinRT API already. So this is calling onto C++. And if you're a JavaScript guy, you're like, oh, other than it's capitalized, like the namespaces are capitalized, right? There's nothing in there that's new, right? Even the method, as you see here, the final method, we actually do lowercase because that's the standard that we use in JavaScript, and that's what we do. Something you should know, and you're going to learn a little bit as I go throughout, is that here, in WinRT, a lot of our APIs, any API that we think is going to take more than 50 milliseconds is asynchronous. So for example, like OAuth, we know that's going to make a web request. We know that's going to take more than 50 milliseconds. So we give you an async API, and we use the promise pattern. Everybody here, like, how many feel familiar with the common JS spec for promise, or deferred if you're a jQuery guy? Right? This is standard patterns for dealing with asynchronous operations. We use that, and we give you, with WinJS, we give you an implementation from promise that automatically wraps all that code. So here we're calling on to native WinRT component. And you see here, like when we do a return, this automatically returns a promise. We take care of all of that for you. It's seamless, right? So you're going to see all those APIs as you go. You're going to be familiar with asynchronous code. For those of you not familiar with promise pattern, here's kind of what it looks like. When you call onto a promise, pretty much all you have is, you say, hey, let me make an asynchronous call. And then you say, when you pass something, you say, oh, there's going to be a function that gets called when there's a success. So I gave you examples here of everything. So here, for example, I'm calling WinJS XHR, and I'm going to make an asynchronous call. It's an XML HTTP request, and then a promise gets returned. And then with the promise, you can pass one function, which is, hey, call. This is where you call back when it succeeded. Or you can pass two functions. One of them is, hey, call these when you succeeded. Call these when it failed. And you even get a third function, which I don't have a sample for, but you can do an extra function here, and that's the one that gets called as progress goes on, right? And that one, not all APIs support. So if you call it and you don't get anything back, make sure that you check the API to see if it supports reporting progress. But that's all that you have to do with a promise,
right? So you're looking at, hey, we're gonna go log into Facebook. How much code is that gonna be? Well, you go download this FB app that one of the guys on our project did for the hackathon, and this code already does everything. If you want to rewrite it on your own, you can go here. It's about 10 lines of code. Most of the logic here is just calling onto the web app broker. He actually has a lot of extra error handling, and that's actually most of the work that you see here. Very, very simple, right? So let's go ahead and run it. So you see here. And well, I'll keep it on the simulator. So right there is my Facebook sample. This is the code that we wrote. If you want to see a breakpoint here, we can go back and just add a breakpoint here so you can see the calls. So I'll put a breakpoint, that way you also see the debugger. And I'll just click login, right? And you see all of the UI. So this is standard UI. It's nice that it's standard because every user will be familiar. It's the same dialog over and over on Windows because everybody uses the same thing. And then here I can actually just go back and do login. And you're going to see these in full screen in a minute, so don't panic because you're like, oh, that's tiny, I can't read it. It's just that I didn't change the default to run on the simulator.
How did you debug CSS?
We have a tool right here called DOM Explorer. And so let me log in and I'll show you in a minute. So that right there called on to the broker, and this is the callback that's coming back. Yes, I'm seeing that, Kathy. But I have to give them to release a few more. So give me 5 minutes. And then, so you have right here, a breakpoint was hit. I can go F10. I can look at my variables. For example, I can look at this query variable right here. Everything that you would expect out of the tools is there, right? And you can get through everything like that. To answer your question on how do you debug CSS, let me show you here. So this is what's coming up. We have inside Visual Studio, we have this thing called DOM Explorer. So if I go here and I just say select an element, right, I can just manipulate, come back here, click on that, and it tells me exactly what the HTML. It gives me something very similar to F12, as you're familiar with it, where I can track the styles. I can say trace this style. I can look at their layout, all their attributes. I can set things on the fly here and tweak it, all that stuff. This is standard F12, so it's going to be very familiar. Right, whatever browser you use, they're all close enough. You use Firebug or whatever, they're all close enough that you're going to be able to get around it very, very quickly. Right? So that's one of the APIs. That's the very first thing we're going to have to do to call Facebook. Right? We're going to get that token. So those few lines of code, you'll download them and you get your token out of that using JavaScript. Go ahead. Actually, no, hang on. I'm going to say questions till the end because she's going to continue nagging me and we have to get through a few things. Come to me afterwards. Yes, I'm blaming it on her. So next thing that we're going to do is let's just make a call and get our profile, right? And for that, we're going to use a standard XHR. We're going to make an Open Graph call on our own. There's nothing that automatically makes the Open Graph call. So let me show you what that looks like, right? So I can go back here, and here's my default JS, and I did it such that, I use different styles of coding for all of these. So for example, right here, on login, I use kind of the style that I use most of the time, which looks a little bit more like jQuery. It looks a little more using WinJS. So login, you can see here, I did a $, which is kind of like similar, or a replacement for jQuery here. And I did AC login, and I added my then functions and everything using kind of a very jQuery/WinJS syntax. For login, for get me, which is just going to make the very first XML HTTP request, the simplest one, I did it just pure JavaScript. So you kind of like anybody that just knows the basic JavaScript, doesn't know a framework, will be able to get through this very quickly. So here I added I say, hey, get element by ID, add an event listener with click, and then all we're doing here is here's how you post onto Facebook, right? Here's how you post to the Graph API. You just say WinJS XHR, you give it the URL, you give it the parameter or tokens or anything you want to pass. This is obviously a GET request, that's the default. And then I handle the promise where, hey, this is what's going to happen on success, and then this is what's going to happen on failure. Something I did here, just to show you some of the functionality here, is this one I here for getting the profile. I did it all with the very basic JavaScript. So what comes back, I'm just doing set the source image, set the class name, everything the way we do in JavaScript. So I didn't use data binding or anything fancy, right? If you look at the other samples, I have samples of data binding. I'll walk you through that in a minute, right? So I'll go ahead and run it here, and this time I'm going to run it full screen, so you can see the actual UI of what we showed you earlier, right? And I'm going to go, so I have to log in first before I can call to get my profile. And, this is standard UI again, and I just click login.
right? You see the breakpoint that we set up earlier, so let's go ahead and do F9 and let it run. You see the token that came back. Now I can make the call to get my profile. You see it came back with my image. It came back with all the, that's all the JSON. I actually did a set inner on the HTML on that JSON just so you would see that, yeah, you can use inner HTML, right? So very, very straightforward stuff. This is how you're going to make the post request. Now the last one is more interesting, mostly because on the last one, I wanted to show you how to call a Win.js control. So let me show you the HTML, and I'll show you what this looks like for us. How the magic happens with regards to using HTML controls. It's going to be very straightforward, but I want to show it to you so that it becomes familiar to you and you have something to refer to. So here I have a div, right? And then all of our the way Win.js works is we extend stuff through the data. This is a common pattern that we use. If you're, for example, jQuery mobile, you would be very familiar with this pattern where we use data dash and then we declare the functionality like data dash role or whatever. Right, so here with Win.js we have data win control, and this says, hey, this div is going to become a Win.js.ui list view. So this list that this div right here is going to become a list view. The magic of Win.js is going to turn it into a list view, right? And then I'm going to say, hey, the data win options is that the layout is going to be a grid layout because we have different layouts. We have a list layout and a grid layout. Right? So this is how you define the list view. Now, this is also using data binding with regards to I actually define a template. So if you go back here, you'll see that I actually define another Win.js control called a data binding template, right? Because I'm going to get all my friends back, and I want to use a template. If you're familiar with jQuery temple, handlebars, whatever, very similar functionality. Define the template, and then let Win.js and put those two together for you. Right? So a few lines of HTML. This is all HTML using JavaScript, using standard stuff, and you have standard CSS. So you see classes and everything to define my control. It's all there. And then I'm going to go back here, and I'm just going to add an event handler. So I got my when the get friends button gets clicked, go ahead and log in if you haven't logged in. Make a open graph call, and then when it comes back, here's what we're doing. First of all, I'm going to say, hey, go find the list view. And remember, we have a div on HTML, right? And we know the name. So I went back and said, hey, go get the div. And then the list view is actually added as a control, as an expando called .win control onto the HTML element. So I just go in there, and every time you go in there, you can find your HTML element. Get 0 just comes back because I use this query-like syntax. But in a normal world, you haven't done document get element by ID .win, and then give it the ID and then .with control. Right? And then here I can go in there and add I added a class so that I would show it. And then I said, hey, create a binding list because it's a list that's coming back, right? And I want to do data binding, right? And then I say, hey, the template for the list view is going to be this template, and the item data source is going to be this binding list that I created. So this just gives you an example. If you look at this whole thing, we're looking at probably 15 lines of code, and we're making one open graph call, and we're data binding into a list view. Right, so let's go back and see what this looks like in real code, in the app. So I can come back here, and Franz is smart enough to check whether I've logged in, because I used to forget. So I'm going to go log in right here.
The question is why?
Why what?
Why do you have to log in twice?
Sorry?
Where is your token stored? I mean, like the whole login to Facebook, right?
Yep.
If I'm already logged into my browser or in another app to Facebook as me,
Yep.
does it mean that my app has to authenticate yet again?
Yes. So the question is, do we have or is there such thing as a single sign-on across all apps? And the answer is no. Every app authenticates separately because every app is in their own sandbox.
That's not correct.
Right? For Facebook.
No, if you authenticate through OAuth and the Facebook through the broker you showed in one app, it will apply to other apps.
And the browser?
Browser separate.
No. So yeah. So
But you go through the web auth.
sideline with the true us because trust me, he's.
So the sign-on will talk to you.
Yep.
Let's take it offline.
Yeah, take it offline because it's
And anyone
technically
who
he won't have the token.
we can do it.
The way you're saying is right, but he won't have the token.
The API that gives you the token.
Well, yeah, but so yeah, so
The UI doesn't come
yeah, so the UI won't come up, but you'll need to get the token. But so talk to us, and we'll give you something. So we have something that makes it pretty good with regards to user experience. But to go back to it, the one app, applications don't share that token, right? Every application has their own little sandbox. So we'll get you through that.
I plan to do that alone.
Can you use the iframe to do the auth? Yeah, you could if your application was using web context and then you passed it on to local context, or you just kept it on the iframe. You could if you wanted to, right? So that's it. So now you see, I got my list box right here. And why do I want to have a list box? Well, for example, like, all this standard stuff, like, the scrolling, all the standard event handlers, like selection, all this stuff's coming for free, once you create a list build, right? So that's why that's how you want to create a control. That's how you would want to do it. And then that's where you'll be at. Let me show you one last thing, and then I'll let you guys go. Because this is interesting, and I think this will be interesting for you to see. So this is a Toaster Cookbook app, which I showed you earlier, and I want to show you this because we tweaked this to have a little bit of Facebook functionality, which I'm not going to show you so we can save time. But this is a full-blown app, written HTML and JavaScript. You're going to see in SAML C# too. We have hands-on lab for this, right? So you can go in there, look at the code. You can look at hands-on instructions on how to build it if you get stuck, if you're trying to mimic some of your functionality. And this is the kind of applications that we would expect that you would write out of, like within 24 hours are reasonable, right? Because it just goes in there, fetches some, recipes. So it's just making some XML HTTP request. It has everything. For example, capturing of images, photo or video is there. You're doing pinning where, for example, I can pin this and add it onto my start tile. So doing a live tile is actually here. So I can, for example, pin this recipe onto my screen, and it'll actually be there already pinned next time I exit, and it's there already now when I exit. It actually has, for example, functionality for search. I showed you earlier how I could search from within the shell. I can also search here. So if I search for anything, you see all the search functionality from within my app. If I click on any of the recipes, I can actually see share. So for example, here, if I go into settings and I say, oops, sorry. So for example, here I can go in there and say, hey, I'm going to share this recipe with existing applications that can post to Facebook and can post to anywhere. Right? So all these applications we have, we give you the source, and this is kind of an example of something that you would want to just take features out of and actually see the code and take advantage of everything. We added Facebook functionality for this. So for example, if I go into settings here, you'll see here the login to Facebook UI and the login to Facebook code that I just showed you is there in this sample. Right? And then, for example, if I want to post a recipe onto my Facebook wall, I can do that too. So for example, here I can say post it to Facebook, and that just posted onto my wall. And you have the source for this, right? So everything I just showed you, I show you the really basics. Hey, here's the differences. Here's how, here's the very basic API differences. And I show you that, hey, here's how the controls would work, right? So that you know exactly how they work. But then you have a full-blown sample that you can go back and say, hey, here's what I can take code out of and do something, more pragmatic for the next 24 hours and get a jump start on my code. That's it. Sorry it ran so long. There was a lot of questions, and I didn't want to leave you guys with more questions than answers.